to add radicals? What teaching tool did I use? Kinda. But what example did I use? What did I do? I took something you knew and we applied it to a new situation, yes? Okay, so let's do that same thing. If I had 2x and I was multiplying by 3x, what would my answer be? 6x squared. Why? Why is it 6x squared, Burke? That covers the x squareds. Why is it 6? Right. So I got 2 times 3, and I got x times x to get 6x squared. So the coefficients multiply together, the variables multiply together, right? Okay. What if I gave you this? 2x times 3y. What's that answer? 6xy. Why are they different? Because x and y are not the same, right? Okay. So now apply that knowledge to a new situation. What is 2 root 3 times 3 root 5? What must that be? 6 root 15, right? Why? Pardon me? Why must that be the case? Why were you able to do this? Damaris. Yes, those are both x's and these are both square roots. Everybody understand? Okay, so knowing that, what is this answer? 2 root 3 times 3 cubed root 5. What do you think is that answer based on what you know? Six root 3, then what? Cubed root 5. You cannot put them together. Why? Because it acts like x and y. They are not like terms. Everybody good? Easy peasy. That's what it was in grade 10. Right? So, let's look at this very first one. What do I got to do? Multiply what by what? So what are the things that are multiplying, Ayaka? What do you call the number that's out in front? Starts with a C, ends with a T, has coefficient in the middle of it. Coefficient. Multiply the coefficients. What do you get? Negative 35. Then multiply the radicals, the radicands. Their arguments is what the way we like to say it. And what do we get? Am I done? Of course not. Why? Simplify, simplify, simplify. When do you simplify? Every single chance you get. In the question, you can. In the answer, you can. In both sometimes, you can. So when should you? Always. What's that? That is 4 times 6. What comes out? 2. What's already out there? So it is negative 70 root 6. Everybody remember how to do it? Easy peasy lemon squeezy, right? In grade 10, you only did this with numbers. What are we going to add to it in grade 11? Variables. That's going to be the only difference, right? But let's make sure we are all good with numbers. Okay? Now, how do you want to do this? That's 12. The answer is 12, yes. What do? You want to simplify root 8 first, right? Okay, that's cool. That's 4 times 2, yeah? So it's root 2 times 6 root 2, yes? Okay. What's the coefficient here? 1. What's 1 times 6? 6. Now, a bunch of you remember the shortcut. If you take the same radicand, root of x times the root of x, what do you get? X, right? Y. Everybody can tell me it's x, and nobody can tell me y. Deepinder, why? That's one way to explain it. Isn't this x to the 1/2 times x to the 1/2? And what do you do with the exponents? Add them. What's 1/2 plus 1/2? X to the 1. That's one way to look at it. You could also look at it this way. Isn't that the same as saying the square root of x times x? Isn't that a group of 2? So what would come out? A single x. So root 2 times root 2 is technically the root of 4, isn't it? And what is the root of 4? 2. 6 times 2, which equals 12. Is everybody good to there? That is where you should be at the end of grade 10. You should be able to do any kind of multiplication question that I ask you right now. You should be able to do it. As long as it's all numbers. Yeah? Okay. What's different about C? Pardon me? Right. So, what does that little 2 mean for that base? Close? Right. Because the negative is part of the base, correct? So 2 negatives, right? That would be technically the root of 36, which is 6. Everybody cool? Okay, what's different about D? It's almost the same thing. What makes it different? It's got a coefficient, right? So that 2 means the whole base happens, right? Which is 4 root 3 times 4 root 3, which you know is 16 root 9, technically, but at this point, you guys are probably okay to say root 3 times root 3 is 3, right? So some of you that are, more comfortable might go right to here and go 16 times 3 and get 48, right? But some of you may need to go through this step to get to the root of 3. 16 times 3 to get 48. Some of you may need to still do this. And I'll use blue. 4 times 4 times the root of 3 times the root of 3. 4 times 4 is 16. Root 3 times root 3 is 3. 16 times 3 is 48. Do I care if you do gray, red, or blue? No. Who is the only person that knows how they like to do these questions? You are. You have to make that decision. Am I giving you a way to do these questions? No. I am not giving you a way. I am giving you many ways. What if the way you like to do these questions isn't one of the ways I show you? It's still okay. Right? Good. Okay. What's happening weirdly in E? There's brackets. Now, just to remind you, if I gave you this, 5x times 3x plus 2, could you do that? What is it? 15x squared plus 10x. Right? Why? What's that called? Does anybody remember? It's the distributive property, yes? Because that 5x distributes into that whole bracket. So, is that not the exact same thing here? It is, isn't it? So what's the first one? (15 root 16). Plus, what's the second one? 10 root 24. And what's the third one?
5 root 40.
Minus 5 root 40. Are you done? Do you have a 1 out of 4 on that scale? Have you minimally met my expectations?
Yeah.
Sure, you've shown me you know distribution, which you learned in grade 7. Right? Should that get you through grade 11? Nope. So then we simplify. What is the square root of 16? It's 4 times 4, so that's 15 times 4, which is 60. 24, we just did up top, is 4 times 6. What comes out? 20 root 6, and 40 is 4 times 10. What comes out?
10 root 10.
Minus 10 root 10. Am I done now?
Yeah.
Yes. Everyone is good? Excellent. Oh my good gravy. What is happening in F? If I gave you this, could you do that?
Yeah.
What would you do?
Multiply each.
Multiply each. In Canada, we have an acronym to explain that. FOIL.
Oh, yeah.
But FOIL is a bad acronym because it only works with doubles. It only works with binomial versus binomial. So I don't like to use it very much. I like to call it what it is. Distribution. If there was no 7 there, it would be x through there, wouldn't it? But there is a 7 there, so you also have to put that through. If it's 3 and 3, you're going to have 6 arrows. If it's 4 and 4, you're going to have 8 arrows. If it's 3 and 2, you're going to have 1, 2, 3, 4, 6 arrows, right? So, what do I do? Follow the example that you learned in the 10th grade. What do you do with the first term and the first term? Multiply them to get what?
72 root 10.
Plus.
48 root 20.
Minus.
45 root 5.
Minus.
30 root 10.
Is it done?
No.
Minimally?
Yeah.
C minus level. Who's happy with a C minus? Good. Fix it up. Is everybody good? Nothing new here, yes? Absolutely nothing new. What is G? It's the same. Some of you are going to do this. Some of you are going to tell me it's 5 root 3 squared minus 4 root 6 squared. Is it? No, it isn't. Why? This is wrong. Even though if I didn't tell you, some of you would have done that. Because you would have said, exponent outside brackets goes to everything inside the brackets, yes? Because you are not learning what you are doing, or you are not learning why something works. You are learning something to do. Why is this wrong?
Because you can just take the root out
Hold up, let Lucas finish, Deepinder.
like 25 times 3 minus 16 times 6.
I see. So Lucas is saying bring that back under there and bring that back under there. Okay, that'll work. Except all that will still have to be squared. So you would have root 75 minus root 96 all squared. Okay, so even if you got to there, a bunch of kids in this room will still write root 75 squared minus root 96 squared. Is that right? No. Why? Thank goodness I'm here. What do those brackets do to that? What do brackets do in math? They group it all as one, yes? Which means everything that's highlighted in yellow there is a base, yes? What do exponents do to bases? What does an exponent do to a base? What does x squared mean? It means x times x. So what does that squared mean to that base? One base, two bases. And when you were there, do you know what to do? Of course you do, because you just did F. Right? Go. I, of course, am going to do the longest, most possible work here, right? Of course you can. Kind of a dangerous move to make this early in the week, but no problem. Yo. Pardon me? Sure. Kind of a dangerous decision to make, but okay. And of course, there is the answer. Do you need to show me that many steps? If you know what you're doing. Do you? No. You guys go ahead and do H, but something looks different there, so be careful. I'll start you off. Remember, if you were just memorizing steps, you are going to make you're going to make your life significantly harder if you are just following steps and not thinking about what you're doing. You decide how you want to handle that. I'm going to pause the recording for a moment. Discuss, please, with your neighbor, I use the word interesting because it's interesting to me, but none of you find it interesting. But I'm going to use interesting. So pretend you're a teacher. Give me your phone. Give me your phone. I don't care. Put it on the desk. What interesting mathematical thing happened with every single one of these radicals? What happened? They all disappeared and came out as nice integers, yes? So what does that tell you you can do if you ever want to get rid of a radical? You can square it, right? Everybody with me? Sweet. Now, we are going to stop there for a moment. Actually, we're going to do this last one. If I want the area of a rectangle, how do I find it? What? Multiply the sides. Length times width. What do I have here? 6 cube root 40 times 2 cubed root 135. Do it. Then we're going to stop for a moment because we're going to do something a little weird. Is it okay to do 12 cubed root 5,400? Is that okay? Is it? Okay. Is it also okay to simplify here and sort it out? Okay. Is it okay to mix the two? What do I mean by that? Well, this one simplifies easily, doesn't it? That's 8 times 5, correct? What's a cube root of 8? 2. So that's 12 cube root 5, yeah? But what if you can't picture a cube root there? Do you have options? Could you break 135 down the old-fashioned way? Would that be okay? Could you leave it as 5 times 135? And then simplify that? That's cool too. Do I care? No. Now, in this case, if you go to here, 6 cubed root 5,400, because that's what it is, right? 135 times 54. Oh, I lie. Or it's because it's 135 times 40. Idiot. 5,400. In this case, this might be a good move. Why? Because isn't this cubed root 54 times 100? And doesn't that become 27 times 2 times 10 times 10? Does that have a cube root? What comes out? 18 cube root. 2 times 10 is 200, right? Could we break down 200 fairly easily? Isn't that 8 times 25? 8 have a cube root? What comes out? 2. So isn't that 36 cube root 25? Now, I found this to be very easy, even though I did the thing at the beginning that I didn't recommend you do. Do you understand where I am going with this? Where? It's possible. What did I do? 6. Oh, that should be 12, shouldn't it? Thank you. 12. 3 times 12 is 36. 2 times 12 is 72. Thank you, Aaron. Why did I do this way that I don't normally recommend? Well, in this case, I found this to be easier than trying to find the cube root that works with 135, because that's how my head worked. Everybody understand? I checked this just because with a 0 there, it's really easy, isn't it? It's 135 times 4 is 13 and a half times 4, which is 54, right? But it's 135, so I add a 0 there, 540. And then another 0, I add a 0 there, 5,400. And as soon as I saw the 54, I realized I can work this more easily in this case. Everybody with me? Do I care what you do? Of course not. But somebody always says, Mr. Myers, why would you do it that way when you said never to do it that way? That's the reason. Did I say never? Or did I say simplify when you can? And what does simplify mean? Make simple. For me, I find that to be simpler, so I'm going to simplify there. Does everybody get it? I don't care what you do. Got it? Okay. We are going to stop there, because that's going to be the beginning of your work. I'm going to do we're going to skip up to 2.4, which is page 40, please. Yep. Where'd he go? Where'd he go? I've lost him. There he is. So we are on page 40. Dividing radicals with monomial denominators. I have to remind you what a monomial is. What is a monomial? Who remembers? Burke? A single what? Term. Okay. So is this a monomial? 3. This is where I'm going to review monomials. Is that okay? Is that a monomial? Excellent. Is that okay? Yes. Is that okay? Why? Pardon? Because it's together. Together by what? What do you mean it's together, Zaro? What does he mean? I've told you that he's right. He says they're together. Multiplication. What about this? No. Soon as you have an addition, you no longer have a monomial. But, what about this? Is that a monomial? Because it'll be 8. What about this? 3 plus root 36.
Yes.
Why?
Because 36 is the square root of 6.
6 is the square root of 36.
So you can plus it.
Yes. Everybody cool? All right. So we all know what a monomial is. Excellent. And of course, we all know that when we multiply x times y, we get xy, right? And we all know if we multiply the root of x times the root of y, we get the root of xy, right? So what math is this? X divided by what? What math is x over y? X divided by y, right? So what is 18 over 6? 3. So what then, following along in our rules, what would 2 root x times 3 root y be? 6 root xy. Coefficients with coefficients, radicals with radicals. So what then, using your noodles, 9 root 18 over 3 root 2. What will that be? 3 root 6. Without me at all, you already knew everything you needed to solve that, yes? Okay, so look what I just gave you. Almost the exact same question in A, yes? What do you do with the coefficients? Divide them to get what? 3. What do you do with the radicals? Radicands, sorry. Divide them to get what? 3. And you are done. Easy peasy lemon squeezy, right? Okay. What's different about B? What's different about B? There's variables, right? So where should I simplify first? I should simplify in there, yes? This is 15x cubed y squared over 3xy. Have we done a whole unit on that? So we can do that in our sleep, can't we? What do I do with the numbers? 5. What do I do with the letters? X squared, yes. Oh, y squared on the bottom, thank you. And that's gone, yes? So what I really have is 15 root what? 5x squared. I get out of my head, Ayaka. Is this done? Why not? Because that's got a square root, doesn't it? What comes out? 15x root 5. Everybody cool? Nothing new, right? Okay, tell me what's wrong with C. You cannot simplify, can you? All right. I'm going to highlight this, and I'm going to do some writing over here. There is no simplification. Now, we come to a rule. Is that a fraction? Does it have a numerator and a denominator? Right. Which means it's technically supposed to be a rational number, right? Everyone agrees? We remember what rational numbers are. X over y. X and y have to be integers, right? Okay. Is root 7 an integer? Root 7. No, root 7 is an irrational number, isn't it? Right? That is not allowed. Irrationals can't be in a denominator. They're not allowed to be there. Do I have an irrational in the denominator now? Right now. I do. How will I get rid of it? What am I allowed to do to fractions that keeps the value the same but the looks different? Burke. Reciprocate. So 1/2 is the same as 2 over 1. So it's not reciprocate. What can I do to 1/2 to give me a fraction that has the same value? Damaris. As long as I multiply by the same number, it keeps the same value, doesn't it? If I multiply this by 37 and I multiply that by 37, I get 37 over 74, and I'm good, yeah? Okay, so I know I can change this value by multiplying by something, right? Everyone agrees? Okay. Now, what else is wrong with what's highlighted in yellow? What's wrong with that? It's written right here. What am I not allowed? I'm not allowed an irrational in the denominator, am I? So I have to multiply this denominator by something to get rid of the radical sign. What is it? Not 7. I could use 3 root 7, but do I care about the 3? I only care about the 7, don't I? The root 7. So I can multiply that by root 7, correct? If I multiply the bottom by root 7, what do I got to multiply the top by? Root 7. What is root 7 divided by root 7? No. 1. Is multiplying by 1 ever going to change a value? Can it change the looks? Sure it can. What is our new denominator? We just did a whole lesson on multiplying radicals. What is our new denominator? You all told me you could do it. No. What is 2 root 6 times root 7? 2 root 42 over what is 3 times root 7 times root 7? 21. Everybody cool? Now, is there any simplifying to do? Where? 2 and 21 doesn't simplify. Any radicals on the bottom? Root of 42 can simplify, can it? What is it? It's 2 times 3 times 7, isn't it? Any pairs? So am I done? Yes. This process is called rationalizing the denominator. And it must be done if you ever end up with a radical, an irrational in your denominator. Does everybody understand? Always do this if you have m over a root of anything, and that is irrational. Everybody cool? Now remember, the only thing we're trying to get rid of is the radical, yes? So let's look at D. What can I do? I can simplify the coefficients, can't I? What is this going to become? Root 5 over 2 root 6, yes? Are we happy with that? For now. What makes us unhappy with it? Root 6, because root 6 is irrational. So what must I multiply by? Root 6 over root 6. Why is that okay? What is root 6 divided by root 6? 1. So, what's root 5 times root 6? Root 30 over this, and I'll change colors, becomes 2 times root 6 times root 6. Root 6 times root 6 is 6 times 2 is 12. Everybody cool? Am I done? Am I done? I am, because 6 is 2 times 3 times 5. Correct? All right. I'm going to do E. I'm going to let you guys go on your own. And you're going to do multiplying and dividing only monomial denominators. I'll tell you when to stop in a sec. What can I do here? You could simplify, you could rationalize right now, couldn't you, Lucas? You could go root 18 over root 18. That's one path. Could you simplify 50 and 18 first? Do I care which way you do it? I don't want to do 50 times 18. I know. I'm just saying I don't want to do it. So I wouldn't do this. But can you? Sure. Doesn't matter. I would do this. That's 25 times 2, right? So that is 30 root 2 over, that's 9 times 2, yes? 15 root 2. Agreed? Okay, well, what's 30 divided by 15? 2. What's root 2 divided by root 2? 1. What's 2 times 1? 2. And you're finished. Now, if I were to go the root 18 version, then I got root 18. So 50 times 18 is 900. 6 root 900 over 5, right? Root of 900 is 30. 6 times 30 is 6 times 30 is what? 5 times 18. What's 6 times 30? 180. Thank you. 180 over 5 times 18 is 90. 180 divided by 90 is still 2. Everybody cool? All right, listen. You are going to do pages. What is left on page 38 and 39. And what is left on 40 to 41. Tomorrow is quiz on what? Simplifying, adding, subtracting, subtraction of radicals. No multiplying, because we haven't gone over it. I will remind you of this. I did not get to a question like this. Root 3xy times root 7x squared y. What is that answer? 21 x cubed y squared. And then what would you do with that? You'd bring out how many x's? 1 x. Could you bring out a y? Yes. And what would you leave under there? 21x. I forgot to go over that. Everybody cool? Yes. And you have the rest of the block to finish it up, which is 18 minutes. Now, tomorrow, your quizzes are short, aren't they? Some of you will finish that quiz quickly, yes? So if you have a few questions left over, is that okay? Yes. Everybody good? Go.